Hello, in this episode of Exploring Rust, we're going to finish up the smart pointers section in the Rust documentation by looking at weak references. It did take me a while to get my head around this, especially since for the past couple of weeks my brain is really like a cabbage. I'm not sleeping so well, too much coffee, and I had to keep going back to this until I finally understood it. But I think I finally do understand it now. It's not that complicated in essence, but the documentation is so verbose, I kind of get lost in what it's trying to explain. So I'll give you a simple example of this, as simple as I can make it, so you'll see how this works. And then we'll go through the example program in the Rust documentation. Actually, there are two examples in there on the page. This is the actual page in question. And the first thing it does is it goes through an example that shows you that reference cycles can leak memory. I basically went through something like that in the last video in order to avoid leaking memory and creating some kind of infinite structure. I ended up using two different kinds of node. One type of node connected instances of the other type of node together, which it actually suggests you can do in the documentation. So I've kind of anticipated this page a little bit in the last video, and in the last video I did create a cyclic structure, but in that case, because the kind of connecting node would get dropped when the program ends, it didn't create any memory issues. The example in the documentation shows you that you can have references referring to each other in a loop, and that would prevent them getting garbage collected. Well, that's not really the right word. Let's say it would prevent them from getting dropped and the memory reused while the program is running. But of course, when the program ends, your operating system will reclaim that memory. So you don't want a situation where you've got a cycle of normal references which will persist for the lifetime of your program and prevent anything getting dropped, unless you really do need that structure for the whole lifetime of your program. Anyway, weak references are a way around this, because the point of a weak reference is it doesn't prevent your objects from getting dropped. So you can have a reference to something without that reference making the object hang around unnecessarily long. Let's take a look. So first I'll create a conventional ref. So I'll call it strong ref1 maybe equals, and we need to use RC here, the reference counter. So let's have use standard RC RC, and I'm going to say RC : new. So that's a kind of conventional reference using a reference counter. We could have multiple of these using RC clone, is that right? I get a bit confused between ref cell and RC, yeah, but ref cell's the one where you need to use borrow or borrow mute. With RC you can use clone to create a new reference and increment the reference count, and all of those references will be owners of the object and prevent it getting dropped. And I can actually print out how many references we've got here. So let's try that. I need a kind of format string here, don't I? So let's put in this, and let's say, okay, this is going to be the number of weak references, and this is going to be the number of strong references. Strong reference being the kind of reference that has ownership and does prevent a thing from getting dropped. And we'll say RC strong count, and I'm going to apply that to, I need to pass a reference to this strong ref1. I think I need a reference there, even though it is a kind of reference itself, I suppose. And then we also want the weak count on the same thing. So if I've got this right, so there's a strong reference, so we should see we've got one strong reference to this object, and I need to supply something there which the reference counter is going to wrap. Let's just have a simple integer here. Alright, so I'll try this out. So cargo run, and yeah, we've got one weak reference. Wait, I've got this the wrong way around, haven't I? That should be there, okay. And now we've got one strong reference and no weak references. Okay, so far so good. So there's nothing new here apart from this weak count thing. Now I can create a weak reference, a reference that would not prevent this from being cleaned up. So I'll say let weak ref1 equal RC, and we use a method called downgrade. So we create a kind of downgraded reference. So I pass in the original reference to the reference counter here, and then let's do this again. Let's print out this stuff again and try that out. So now we've got one weak reference and one strong reference. How do I actually use these weak references? The thing is, you don't use them directly. You have to actually get a kind of normal reference from it before you can use it. So I can use if let, for example. So let's say if let sum, because we're going to get an option here. I'll just call this, can I just call it ref? No, probably not actually. I'll just call it R, maybe. And I'm going to set that equal to, and we're going to use this weak ref. So I use the downgrade method of RC, kind of like a, what do you call them? Like a static method. I don't think that's the right term, but a class method. Wait, let me just look this up. I know there's a term for it. If I go to Copilot, let's not worry about punctuation. What's a static method called in Rust? I can just make this fit the recording area. Let's try that. Copilot is absolutely great. You don't even have to log in. So, okay, it doesn't actually give me a name for it here. Anyway, it's basically just a function that doesn't have a self-reference. That's what that is. And then to actually use it, we call the upgrade method. So this is a method directly on the RC object. In fact, this isn't an RC object, is it? The type of this is actually, I believe, weak. And because we're wrapping an integer, it's going to be I32. That's the type of it. This is standard RC weak. So we call the upgrade method on this weak thing. And then, so if I've got a value, which I should have, we should be able to print this value. So let's put R in there. Maybe let's put in value colon to make it a bit clearer. And I can also do a print in here. Let's put a print here of the weak and the strong count. Maybe indent that a bit. And I'm going to do the same thing. Where are we? That's got to be indented. And I'm going to do the same thing after this if let block. Let's just try to get the indentation right. I don't really want to run cargo format because I think it's going to put all that stuff on one line. And I don't find that too clear. So this upgrade method, the thing is, the reason why we need an if let, the reason why it returns an option, is that remember the point of a weak reference is that it doesn't stop your objects from getting dropped. They're going to get dropped when there are no remaining strong references to them, when the reference count is 0, in other words. So if this object has been dropped, this can actually return none, or rather this can actually return none. And then we just wouldn't do this if let block. But since we do have a strong reference to it, we've got one right there, which is still in scope, then this should work. And we should see here that the strong count is actually going to be 2, because this is actually a new strong reference to the object. But this is going to be scoped to this if let block. So when we get down here and we do this, the strong count should go back to 1. And then, of course, after we hit the closing bracket, the strong ref goes out of scope and the thing gets garbage collected. That's the theory of it anyway. Let's try it. Okay, closing delimiter. What's that? Mismatch closing delimiter. Oh, I hate these so much. What'll I do? So that matches with that. I've got something missing here, right? I think I've deleted that by mistake. Okay, let's try that. Okay, yeah, I can't refer to weak without doing an import. Let's put the import in. What I want is standard RC weak, because this is associated with this RC thing. I don't think you can use it separately as far as I know. All right, let's try this. Yeah, so you see that within that block we got the value, and you see the strong count is 2, and then after the block the upgraded strong reference that we got so we could print this out goes out of scope, and we're back to 1 weak reference and 1 strong reference. Okay, so that's that. And you can find this in my notes at blog.caverprogramming.com. Now what I want to do is go through the tree example in the Rust documentation so we can take a look at this actually being used in practice. So I'll maybe just copy this to somewhere else. What if I just go into the source folder and I can do cpmain.rs to, I'll call it refs.rs or something. And then, so that's not going to get compiled by default. And I can just now, in this copy here, let's just clean this out and get rid of all that. Now I've shown it to you. So with a tree structure, if you just want each node to have multiple children, that's fine. But if you potentially want nodes to be repeated within the tree in some kind of sense, that introduces some big complications. And you may also want each node to have a reference to its parent. And that's the kind of situation where we could use a weak reference. So here, let's create a struct node for a node in the tree. And that can keep some kind of value or string or something. Let's make it i32. And I'm going to have some children in here, some child nodes. Now I want to be able to modify these even if I've only got a immutable reference to node. And for that reason, I'm going to use refcell, which, remember, implements the interior mutability pattern. If we wrap everything in a refcell here, then we can modify it even if we've only got an immutable reference to a node. And then to store a list of nodes, I'll use vec here. Now I want it to be possible to use the same node in different places. At least I think that's the intention of this example. So for that reason, I'm going to use a reference counter here, because we can have multiple references to the same node if we do that. And then finally, we've got a node in there. So we've got something that's modifiable, and the thing that we've got is a list, and it's a list of reference counts to nodes, so that I presume we could have the same node in multiple places. All right, so that's that. Well, I just got a delivery from Amazon that I didn't get to on time, so that's interrupted my train of thoughts. I think I was saying that we should be able to have a node in multiple places in this list because it's reference counted. Now, what I also want is I want each node to have a reference to its parent. But if a node gets dropped, I want all the children to be dropped. So it's great that this has ownership of the children, but I don't want the node to have a strong reference to its parent, because then the parent will hang around as long as the children still exist, and the children will hang around as long as the parent still exists. And as far as I can see, nothing will ever get dropped. So this is one reason why we might want a weak reference here. So I'm going to say parent. We'll make it a ref cell again so that we can modify it. So with a capital C. And this is going to contain a weak reference. And it's going to be a weak reference to a node. Now we'll create an actual leaf. So this would be like the terminal node in a tree somewhere, a terminal node. Let's say leaf equals. So I'm going to wrap this in a reference counter. And in there, we'll create a new node, put the brackets in. So the value could be, for example, 3 or whatever. The parent, well, here we can use ref cell : new. And what do we have to create a new one of? Well, we need a weak reference. And I can create a weak reference that doesn't refer to anything, just so that we can get this up and running before we have anything for it to refer to, using weak new like this. Then there's the children. So this can start off as being an empty list. So let's say ref cell : new again, and then we can use the vec macro with square brackets here to create an empty vector. That should be a comma, shouldn't it? And this should be a comma as well. So I think this will work. Let's see if it compiles and runs okay. Okay, I've got to import standard cell ref cell. Let's do that. So use standard cell ref cell. Try that. Yeah, now it's fine. Now let's take a look at the leaf parent. So I'm going to say println, and here we'll say, and this is straight from the Rust documentation, leaf parent equals, and let's put in this stuff. I can't actually print this at the moment, but let's pretend I can. we can do leaf, and remember that's a ref cell, so we need borrow or borrow mute. So I'll call borrow, sorry, I meant to put parent in there, so leaf.parent.borrow, and then we'll call upgrade, which if it was valid would give us a sum option that contains some kind of actual value, which should be a reference to some actual node. To make this work, I have to put in here above the node hash and derive, and with a capital D, debug. All right, let's try that. Yeah, so it says leaf parent none. So this weak new produces kind of an empty reference that is just going to get us none when we do upgrade on it. But now I can create a branch so that the leaf will be a child of the branch. It will be attached to the branch. Let's say let branch equal rc new, and then in here I want to put node, and we put the brackets in. Value, let's make it 5. The parent is going to be, okay, so we want a ref cell in there. So we want ref cell new. And this isn't going to currently have a parent. So there we just use weak new again. And then the children. So again, it's going to be ref cell new to create a ref cell. And again, we can use the vec macro to create a vector. And this time we want to use rc clone to get another reference to this leaf. So that's already a reference to the leaf, but we can clone it to get another reference to the leaf. So we've got two references that refer to this leaf, and the reference counter is at 2 for that node. So we just put address sign or reference sign leaf in there. Now maybe let's print the weak and strong counts for the leaf and the branch. So here I could put print ln leaf, weak is going to be that, and strong is going to be that. And here we just want rc weak count, and I can put in just leaf in there, I think, leaf, and rc strong count and leaf again. I'll maybe put that on a separate line. Let's just run that and see if that works okay. I think it should do. Okay, I'm missing something here. Line 23 or 26 maybe. Oh yeah, that should be a comma, not a semicolon. Right, try again. Missing tokens in macro arguments. To me that looks alright. Is there some problem above that? Oh, have I just missed off a colon? Yeah, so okay, let's put that in. Alright, let's try that. Yeah, I've typed left instead of leaf somewhere. I did that earlier on as well. Okay, when I was trying to run through this stuff. Alright, let's try it now. Okay, we're there in the end. So we've got leaf parent equals none as before, and then we've got leaf weak is 0 and the strong is 2. Where are those two strong references? First one's there and the second one is here, because this branch actually owns its children, including, well, it's only got one child, it's got this. Then I want to take this and do it again for the branch. So let's put branch, and going to copy that and put that in here, and we'll take a look at that as well. So if I run that, yeah, we've got branch weak 0 and strong 1, because we've only got one reference to that branch. It's right here. Now the thing is, I can set the leaf's parent reference to be the branch, because the branch kind of ends in the leaf. In fact, let's maybe do that here. So I want to say leaf.parent, and since that's a ref cell, I need borrow or borrow mute to refer to whatever it's holding on to. And in this case, I want to change it, so I want to use borrow mute. I'm going to set that equal to, and now I want a weak reference to the branch. No, wait. Yeah, that's right. I want a weak reference to the branch. So rc downgrade, and we put in there the reference to the branch. Now let's see what we get. Yeah, I've got a problem there, which is that I forgot that to assign to this reference, we have to dereference it with a star like that. So I think it will work now. Yeah, so we've got one weak reference to the branch now and one strong reference. Strong reference is that. The weak reference is this leaf parent, which has a weak reference to the branch. Now here's a question. What happens when the branch goes out of scope? Or what do we want to happen? We would still want this to refer to the leaf. That should still be a valid reference if that's in scope. But if we drop the branch, the leaf has only a weak reference to the branch. And we should find we've only got one strong reference to the leaf left, because we would have eliminated this by dropping the branch. So let's just put all this in curly brackets to reduce the scope of it. I'm going to put another curly bracket down here and select all that stuff and just indent it a little bit. All right, so when we hit this bracket, the closing bracket here, the branch goes out of scope, and then we can take a look at the leaf again and see how that looks. So we're printing some stats on it here, and then we're printing stats on it here. If I could just line it up a bit. Let's try that. Yeah, so you see that, what have we got here? We did have 0 weak references to the leaf, that's correct, and 2 strong references. After we create the branch, we've got 1 strong reference to the branch and 1 weak reference to it, because the leaf has a weak reference to the branch. After we drop the branch by hitting that closing bracket, we've then got still 0 weak references to the leaf, but now we're down from 2 to only 1 strong reference to it, because the branch has been dropped, meaning we decrease the reference count of the leaf that it refers to. And the leaf could then be dropped were it not for the fact that we've still got this reference to the leaf. So this is the kind of behavior that we actually want. And the documentation actually prints the branch at some point, or the leaf, I forget. Let's try printing the branch, I think. So after we create the branch and we set the leaf parent, let's do print ln and try printing it. So I put some stuff in here. Let's put the kind of debug print thing in like that. And I want to print branch, I think. That should probably work because I've put derive debug above nodes, so it should be possible to print it. Let's try this. Yeah, and you can see that here we've got node. So we've got value 5. Which one's that? Yeah, so value 5, that's the branch. And it's got a parent, which is a ref cell containing a weak reference. That doesn't print, so we don't get some kind of recursive printing. And then we've got the children, which are strong references. And now you can see we've got the leaf printed with the value of 3. And the parent of that is a weak reference, which again doesn't print, so we don't get recursive printing. I think that all works as expected. So I'm quite thankful that we've now reached the end of the section on smart pointers, because right at the moment I don't feel I've got the mental energy for much more of this. So we'll get on to the next section next time, which hopefully should be something interesting. I'm wondering how we could have the same child in multiple places. I suppose I'd have to create a bigger tree to do that, wouldn't I? Potentially I could add the branch in as a child of the leaf, but that's probably not a good idea. So I tried putting this code in Copilot and asking it, and it came out with the answer that I expected, which is that you could have multiple branches here, and there's no reason why you can't reuse leaf using RC clone as the leaf for multiple different branches. And I don't see why, for that matter, we couldn't even have 2 identical leaves right here if we wanted. So I think we've done what we set out to do. Hopefully so, because this example is directly from the Rust documentation. Okay, so that's it for this video. You can find the write-up of this, at least the first bit of it, and I'll also put this code there as well on blog.caveofprogramming.com. Until next time, happy coding.